And the second topic is common source amplifier. Here I have drawn the circuit of the common source amplifier, in which we see there is a resistive load RD connected between the VDD and the drain terminal. Now how we can identify it is a common source amplifier configuration? When the output is taken from the drain terminal, this indicates it is a common source configuration. Now we have to draw the equivalent circuit of this common source amplifier. For this we have to again ground the DC sources. When we ground this DC sources, we will get the circuit like this. Let's start. As we have made in the previous lecture, in the similar manner we will draw the equivalent circuit in this for this common source amplifier. As we can see, it is the gate terminal, source terminal, here also source terminal, this is the drain terminal, this is plus minus VGS, and here we are applying the Vin, and this is equals to GM VGS. When we are considering the channel length modulation, then we are going to use the R0 over here, okay. And as we can see here, we have applied the resistive load RD. When we will ground this VDD terminal, so this pointer D, as you can see over here, and this ground terminal over here. So this RD will be placed between these two terminals. This is the equivalent circuit of the common source amplifier in the similar fashion as we have done in the topic 1. It is a small signal. It is the small signal model of this common source amplifier. Common source amplifier. Now we are going to apply the KVL at the input side. This is the input side. So as we can see from here, there is no current. I is equals to 0. This implies this V in is equals to VGS. Okay, this is our first equation, and we are going to apply this K. Okay, let us consider this is as point A. Applying this is KVL at input and applying KCL at node A at the output section. From this, as it is we output this the potential at this node A is equals to V out. Now applying KCL, since the current is going outward from this node A, the potential difference between this and this point is equals to V out, and this is grounded, so minus 0 by RD. This is RD, and this similar way V output minus 0 by R0 is equals to 0. As we can see, this VGS is equals to V in, replacing it. V out by R0 is equals to 0. Taking common this V out and taking this GM V in this side, right hand side. So we get 1 upon Rd plus 1 by R naught minus Gm V in. Now as this is the parallel combination, V out is equals to Rd parallel to R naught minus Gm V in. Now for the voltage gain AV is equals to V out by V in. So bringing this V in this side, okay, as it is the parallel combination, it will come in the division side. So when we cross multiply this, we get minus Gm Rd into R naught. As this 1 upon Rd plus 1 upon R naught is equals to 1 upon R equivalent. So this is in the denominator. Okay, we will multiply this at the right hand side with the Gm. So the voltage gain is equals to minus Gm Rd parallel with R naught. This is the voltage gain. Now we will determine the current gain, AI. Current gain is equals to output current by input current. As we can see here, the current input current is 0, so out by 0, it is equal to infinite. Current gain is infinite. Okay, now the third parameter is input resistance, or we can say input impedance. Now the third parameter is input impedance. R input is given by V input by I input. As the I input is equals to 0, so this R input will equal to infinite. Now the fourth parameter is R output impedance. For calculating the output impedance, we have to consider this small signal model. In this we will this this V input will be short circuited, and we will place consider a voltage source at the output. The circuit is like this. As I said, we will short circuit the input. This V in is equals to 0, and we will consider the voltage source Vx at the output, and let us assume Ix is the current given by this Vx. Okay, so we will consider a node A over here, and we will apply KCL at node A. Since the current is going outwards, Gm Vgs, and over here this at node A, the potential is equals to Vx. So Vx by R naught and Vx by Rd. Since at node A the current Ix is coming inwards, it will come minus Ix. Okay, since this VGS, as this VGS is equals to V input and V input is equals to 0, this will be 0, and taking Vx common from this side, 1 upon R naught 1 by Rd minus Ix is equals to 0. So this is again the parallel combination, Vx divided by Rd parallel with R naught is equals to taking Ix right hand side at right hand side, and the output impedance is given by Vx, output voltage by output current. So Vx by Ix will be equal to Rd parallel with R naught.